Hello and welcome to our first video lecture of the year, an introduction to functions. We're going to be dealing today with some basic review from Algebra 1. So feel free to make the video go as quickly as you want it to, because hopefully this is old news to you. First thing we're going to talk about is slope. Slope is your rate of change between two things, between 2 points. They could also be a rate of change between two events, such as what is the vertical and horizontal distance between 2 points geographically, such as bottom of a hill, top of a hill, maybe going down 100 feet but only over 50 feet, something like that. The slope formula is defined as slope, or m, is equal to change in y over change in x, which is y2 minus y1 over x2 minus x1. So difference of your y's over your difference of your x's. So for example, find the slope of a line that would pass through each of these pairs of points, through negative 2, 0 and 3, 1. Well, in identifying these as x1, y1, x2, y2, then I would say that slope is equal to, I write my formula down because that helps me remember it, y2 minus y1 over x2 minus x1. I basically just plug in what fits where, so 1 minus 0 over 3 minus negative 2, which becomes 1 over my 3 minus negative 2, I slash and dash to get 3 plus 2, which is 5. So my slope is a slope of 1/5, which means for every value that I go up, every time I go up 1 point, I simultaneously have to go to the right 5 points. Okay, once again, my slope formula, y2 minus y1. I always like to write my formulas because if I write it, then it's there to look at. I don't have to remember it while I'm figuring out what to put where. Just a good practice all the way around. So my x1, y1 are negative 1 and 2 respectively, and 2 are x2 and y2 respectively. So I have that m equals 2 minus 2 over 2 minus negative 1. So I have m equals 0 over, slash and dash, 3. 0 divided by anything is 0. Now remember, if I had a 0 in the denominator here, down under might, if the 0 had been down under might, then you would have an undefined slope. Friends, don't let friends divide by 0. You just don't do that in a math class. It basically means that you have an infinite rise and no run. A 0 slope, when 0's on the top, means you have an infinite run and no rise. A 0 slope means it's just a straight horizontal line. A undefined slope is a vertical line. It's voidical. The point slope form of the equation of a line works really well for if you have an equation with 2 points. It really makes it kind of easy just to plug it in, as the Glade commercial tells us. The standard form of it is y minus y1 equals m times x minus x1. The beautiful thing about this equation is that it is already set up to have slope and have a point. If all you have is 1 point and a slope, you're beautiful, you're golden, you don't have to calculate a y-intercept. So I'm just going to simply plug it into that. So if I have y minus y1 and it equals the slope times x minus x1, I know my slope of 3 is my m value, and these right here are x1 and y1. So now I have y minus negative 2 equals 3 times x minus 1. So y plus 2 equals 3 times x minus 1. And I'm fine with that. That right there, that is my solution, because and it said slope intercept here, I really wanted point slope. Okay? I really wanted point slope. Is what I wanted there. But if I wanted to make it slope intercept is the format of y equals mx plus b. So then all I'd have to do is distribute my 3 through and subtract 2. And I'd have my answer anyways. Okay? So this shows you can use this format to plug it into the equation to get yourself something quick and then be done with it. Otherwise, if you start with the y equals mx plus b format, you're plugging in your x, you're plugging in your y and your slope, and you're having to solve for the y-intercept. Same amount of work really either way, but this shows you 2 ways to do it. The slope-intercept form of the equation of line is the version that I prefer, which is y equals mx plus b. Your m is your slope. Your b is your y-intercept. This is the format that most math teachers prefer, because this is the format that allows you to plug it into a graphing calculator, plug it in, get your graph, look at it, go, walla walla, bing bang bong. Okay? Really, what I kind of like to teach my students is that when you are confronted with an equation, as we'll see in this next example, of determining the slope and the y-intercept of each equation, and then sketching its graph, I like to teach my students that this is about letting the equation speak to you. Math is a language. People don't realize it. You know, really, math should be in the foreign language department in some ways, because it is a foreign language. You have to learn to think in a new way. You have to learn to think in math terms. And so you also have to have a conversation with your equation and see what it can tell you. With most equations, especially when it comes to graphing, if you ask the equation the right questions and let it speak to you, you end up doing very little work for graphing. And in pre-calculus, we do a lot of graphing, so I'll teach you this. What it tells me to do first is determine the slope, which is my m value, and the y-intercept, which is b, of each linear equation, and then sketch its graph. So I look at it for A. The slope, the m value is 2. The y-intercept is positive 1. Remember, it's the entire sign there that gets included with it. If it was a minus 1, it'd be negative 1. And then my graph, I just draw a graph here, and I go up to a y-intercept of 1. I go up to 1 on the y-intercept, and my slope is up 2 and over 1. Up 2 and over 1. So now, there's my graph. Now, if I were using the point slope form that we had on the last page, what I would do is I would graph the point that's there. And then I would graph the slope from that and get the sketch. For the next one, y equals 2. Well, for y equals 2, the slope, what's my m value? The slope is 0. There is no slope because there's no x value there. Simply what the equation of it is that y is simply all instances where you have the value of 2. The y-intercept is going to end up being 2. Because what this equation will do is for all values on the y-axis, where y equals 2, this equation will cross that. So there are an infinite number of x values. You're going to have 1, 2, 2, 2, 0, 2, 3, 2, a billion, 2. But where I have a y equals anything, it's a horizontal line because it's inclusive of all values where y is equal to 2. On C, I have an x plus y equals 2. In order to really get this into the equation or the format I need, I have to take it out of the y equals mx, or put it into the y equals mx b format. Meaning I have to start with my equation of x plus y equals 2. I need it to be in the y equals mx plus b, which means I need to isolate the y value in order to find what I'm looking for. So what I'm going to do is I'm going to take x plus y equals 2. I'm going to subtract x from both sides, and y will equal negative x plus 2. Remember, I want it in this format. I've been given it in something else. Okay, I've been given it another format. So now I can see my slope. My slope is negative 1, and my y-intercept is 2. Which means, when I go to graph this, I'm going to go to 2, and I'm going to have a straight line that goes like so, like so. It's going to go down 1 over 1, down 1 over 1. And so what I end up getting is just a straight line that looks like that. Notice how the negative slope flips the graph from going from bottom left to top right. It goes from top left to bottom right. Parallel and perpendicular lines, okay? All determined by slope. Parallel lines, slope 1 equals slope 2. The slope of the first line equals the slope of the second line. Because they're parallel, they will also never intersect. Remember in Algebra 2 and Algebra 1 when you dealt with solutions of linear equations, and we'd give you two equations, and we'd say find their intersection. With the parallel lines, there is no intersection because they never cross. Perpendicular lines the slope of one is the negative reciprocal of the other. Let me say that again. The slope of one is the negative reciprocal of the other. So in this case, I would say that I'm going to write negative reciprocal. So in other words, if I said the slope of one line is 2, its perpendicular slope, the slope that's perpendicular to it, is negative 1/2. Okay, because I take the slope of 1, flip the fraction, and change the sign. So find parallel and perpendicular lines. The slope-intercept, find the slope-intercept forms of the equations of lines that pass through the point 2, negative 1, and are parallel and perpendicular to the line 2x minus 3y equals 5. Now they've told me slope-intercept form. This is y equals mx plus b. That means that I need to take this equation and I need to put it into that format. It needs to match that appearance. Think of it as I'm forcing the equation to be in dress code. It needs to match everybody else. So 2x minus 3y equals 5. I'm going to subtract 2x from both sides. And then I need to get y by itself. Well, negative 3 is multiplying y. I undo and multiply by dividing. So now my negatives cancel out. I get 2/3 x, and I get minus 5 over 3. So now That's the equation of the line. So I need parallel and I need perpendicular. Parallel line is going to have the same slope, and it's going to pass through the given point 2, 1, 2, -1, and it's going to have some y-intercept such that it's going to be parallel to the original line and it's going to pass through that. But the slope is the same. Perpendicular is the negative reciprocal of that. So a perpendicular line is -3/2 instead of +2/3. So what I do at this point is I need to solve for my y-intercept. I'm going to plug in 2, -1. So -1 equals 2/3 times 2 plus b. -1 equals 4/3 plus b. Now I've got a bit of a sticky wicket here. I've got a fraction and a whole number. So what I'm going to do is I'm going to take the whole number and I'm going to make it into a fraction that matches the denominator on the other side. It's over 3. Well, if I have 3 equals, then I have 3/3. So I have -3/3 equals 4/3 plus b. I need to solve for b to isolate it. Subtract 4/3 from both sides. And I get -7/3 equals b. So my equation is that y is 2/3 x minus 7/3. So the y-intercept of the equation that is parallel to the original line and passes through that point is -7/3. Now I'm going to do the same thing that I just did over here on the right. So -1 equals -3/2 times 2 plus b. Oh, this is a much nicer equation. My 2's are eliminated. So now I have -1 equals -3 plus b. I add 3 to both sides. I'm sorry, and I forgot. No, I'm solving for b. That's right. Add 3 to both sides, and I have 2 equals b. So now, when I plug it back in to the equation right here, I have a slope of y equals -3/2x, and I have a y-intercept of 2. So what this has given me are two equations. The equation on the left is parallel to the original equation and passes through the point 2, -1. The equation on the right is perpendicular to that line and passes through that point as well. And that concludes our lecture for today.